In this video, I will discuss about modulus function. Modulus function is related to the absolute value. The absolute value can be written in the form of a parallel line with a number. So by the definition, absolute value of x is an x if the value of x is greater than 0, and a negative x for the value of x smaller than 0. For example, if I have absolute value of 4, since 4 is greater than 0, so that means for absolute value of 4 is equals to 4. Because for x greater than 0, the value will be equals to x. So 4 will be equals to 4. But if I have a negative 2, absolute value of negative 2, since negative 2 is smaller than 0, so the definition is equals to negative x. So negative 2 equals to 2. And we can also take the absolute value geometrically using the number line. So the absolute value means the distance of x from 0. After we know the definition of the absolute value, now we can continue to the modulus function. So modulus function can be given as fx equals to the absolute value or the modulus function of x can has two possibilities. It will be equals to x for x greater than or equals to 0, and it's equals to negative x for x smaller than 0. So that means if we want to take the graph of the function, we have to draw it this is fx equals to modulus function of x. So it is equals to x for positive values of x. So that means we can just draw a line of y equals to x. So it's passed through the 0, 0 and has the gradient of 1. So I can draw this. This is the line y equals to x. And also, fx is equals to negative x for x smaller than 0. So this is the line of y equals to negative x. So the gradient is negative 1 and pass through the origin. So we can just draw this. The gradient of this is the line of y equals to negative x. Or in another method to draw the modulus equation is you can just draw the original function of fx equals to absolute x. So first you can just draw y equals to x. Yeah, y equals to x has the gradient 1 and pass through the 0, 0. So it will be like this. But because the absolute value can has two answers, it can be a positive for positive x values, and it will be the negative x for negative x values. So that means for the x positive part, it will be the same. So stay the same. But for the negative part, it will become a positive number. So that means all the coordinates here will be reflected by the x-axis. Yeah, so it will be reflected, so like this. So the final answer is this line, the blue line. So all the negative values will be mirrored by the x-axis to the positive y-axis. Example, sketch the graph of the absolute value of x minus 2. So the modulus function, absolute value and modulus function are the same here, only difference is in name. So based on the definition, we can say that the absolute value of x minus 2 can have two answers. It is a positive x minus 2 for the x minus 2 greater than 0, and it is a negative minus x minus 2 for the negative region. So that means we can simplify. It is x greater than or equals to 2 and x smaller than 2. So 2 is the zero maker. So when we draw this, we can draw 2 at the x-axis. So in here, let's see, the 2 is on the x-axis. And then it will be a x minus 2 for x greater than 2. So you can draw the line with equation x minus 2, the gradient is 1, and pass through the negative 2 in y-intercept. So like this is negative 2. For x greater than 2. And for y less than 2, it will be a negative x plus 2. So the gradient is negative and pass through the 0, 2. So 0, 2, and then draw the negative 1 gradient. So it will be like that. Or if we use the same method as before, so you just reflect the coordinates on the negative values by the x-axis to the positive values. Just reflect it. Negative 2 will become 2. This coordinate will become 1. So this is negative 1. Yeah, so just bring it to the positive value. Now, after we know how to draw the modulus function, now we want to try to solve the modulus equation. There are two methods in solving the modulus equation. The first one, we can use the sketch. So we can draw it first, and then we can find the intersection between the two modulus functions. Or the second method, we can use the algebra by using the definition. Sometimes sketch will help us to show the region, especially in the inequalities. After this, we will discuss about inequalities. But let's see the algebra method first. For example, solve absolute value x plus 3 equals to 6. So if we are using the definition, the x plus 3 will be equals to x plus 3 for x plus 3 greater than or equals to 0. And it is a negative x plus 3 for the opposite region, smaller than 0. So from here, we will have x should be greater than 0 for negative 3, And from here is x smaller than negative 3. And then, so that means we can draw it and put negative 3 in the x-axis. So we draw it, negative 3 in the x-axis. And then it is a positive for greater than 3. So we draw the line y equals to x plus 3. The gradient is 1. And cut the y-axis at 3. Yeah, 3 is the y-intercept. So it cuts here, 3, and then draw it. So we have this. And for the region smaller than negative 3, it will be the negative x plus 3. So we draw the line of y equals to minus x minus 3. So it cuts the y-axis at negative 3. Here, negative 3, with the gradient of negative 1. So it will be here. So this is the sketch of absolute value of x plus 3. Now, we want to solve the absolute value x plus 3 equals to 6. So that means we need to find the intersection between the function of absolute, the modulus function, and y equals to 6. So that means we want to find the intersection between the modulus function x plus 3 and y equals to 6. Y equals to 6 is the horizontal. So if I draw y equals to 6, so this is 6. And then I can draw a horizontal line. So we can see that the line and the modulus function intersects at 2 points, here and here. So this is negative 6, 6, 7, 8, 9. So this is negative 9. And this one is 1, 2, 3. So this is 3. So the solution to this equation are x equals to negative 9 or x equals to 3. Based on the sketch, we can see that there are two solutions. There are two intersection points. That's if we use the sketch method. Now, if we use the algebra, so we can use the definition. The modulus function of x plus 3 again, we can use this definition. So based on the definition, we can draw the number line and we can put the negative 3 as the divisor of the region. This is negative 3 as the divisor of the region. For x greater than negative 3, the function is equals to x plus 3. But in here, for x smaller than negative 3, the function is negative x plus 3. So in here is negative x plus 3. So we can find the solutions. So we're in the region of x greater than or equals to negative 3. The function is x plus 3 will be equals to 6. So that means x equals to 3. Now, we have to check whether the answer, the solution here is in the given region. So This solution is for the region x greater than -3. And that this is correct because 3 is greater than -3. So we can take this as one solution. And for the other region, for x smaller than or equals to -3, there is no equals here. The value will be minus x plus 3 equals to 6. So minus x minus 3 equals to 6. Minus x equals to 9. So x equals to -9. And then we have to check again. Is -9 smaller than -3? Yes. So that means we can take both answers, the -9 and 3. So the solutions are x equals to 3 and x equals to -9 here. So this is how we work with the definition. Number 2. Solve modulus function of x minus 4 equals to modulus function of 2x minus 1. So if we use the definition, I will focus on that because we cannot draw it accurately without the grid. So it will be better if you solve it using algebra. So based on the definition, for absolute value of x minus 4, it can be a positive x minus 4 for x minus 4 greater than or equals to 0. So x greater than or equals to 4. And it can be a negative x minus 4 for x minus 4 smaller than 0 or the opposite direction. So using the number line, this is 4, the divisor of the region. So greater than 4 is a positive function and smaller than 4 is a negative function. That's for the first function, or the left function. Now, how about the right function? The right function is also a modulus function. So we have to use the definition as well. So 2x minus 1 can be positive for 2x minus 1 smaller, greater than or equals to 0, or it is x greater than or equals to 1 over 2, and it is a negative 2x minus 1 for the opposite. So that means using the number line, this is half, it will be a positive over the region greater than half and a negative in the region smaller than half. So to construct this equation fully, we have to combine the two modulus functions. So we can combine it together. So we have 4 and we have half. For greater than 4, we will have, I use the red one for the left one. Greater than 4, it will be, okay, this is the divisor, x minus 4. And smaller than 4, it will be minus x minus 4 and negative x minus 4. Yeah, we have 3 regions here, so we have to determine in which region the function. In that region, the function is positive or negative. And the red one, the blue one for the right part. So greater than half is 2x minus 1. So greater than half, 2x minus 1, 2x minus 1. And smaller than half is negative 2x minus 1. So that means we can divide it in the three cases, three regions. So for the case 1, for x smaller than half. So for x smaller than half, we have this. So negative x minus 4 is equals to negative 2x minus 1. And then we solve this. Minus x plus 4 equals to minus 2x plus 1. So that means x equals to minus 3. And then we have to check the answer. Is negative 3 smaller than half? Yes. So we take this. Case 2, the middle one. So the case 2 is for x between half and 4. So we take the negative x minus 4 equals to positive 2x minus 1. So that means this is negative x plus 4 equals to 2x minus 1. So negative 3x equals to negative 5. So x equals to 5 over 3. Check again, is 5 over 3 in this region between half and 4? Yes, so we take this. And then case 3. So the last case, the last region, for x greater than or equals to 4. So we take both are positive. So x minus 4 is equals to 2x minus 1. So that means negative x equals to 3. So x equals to negative 3. Is negative 3 greater than 4? No, yeah. So we ignore this answer. So that means the solutions are x equals to negative 3 and x equals to 5 over 3. Yeah. So you have to check your answer. Is it in the correct region or not? Is it correct for the region, for the specific region or not? Just take the correct answer. If we can guarantee that the both sides are always positive, so we can just simply square the both sides. So this is the same example, if you see. And then I try to use this one. So we just square both sides. So it's x minus 4 equals to 2x minus 1. So I squared both sides because I can guarantee that this is always positive since both are absolute value. So it will be always positive. So I can square it. And this is equals to x squared minus 8x plus 16 equals to 4x squared minus 4x plus 1. And then we simplify into 3x squared plus 4x minus 15 equals to 0. And then we factorize this. So this is 3x, this is x. And to become 4, I have to put 15. It's 3 times 5. So I can put 3 here and 5 here. And to make it 4, so 3 is times minus 3 is positive 3 is 9. And x times negative 5 is negative 5. So 9 minus 5 is 4. So that means x equals to 5/3 and x equals to -3. So the answers are the same. That's it. Number 4. Now, solve modulus function of 2x minus 1 equals to x plus 4. In this question, the right part is not always positive. It can be negative. So we cannot square both sides. So we have to use the definition. So definition of absolute function 2x minus 1. It can be a positive 2x minus 1 for 2x minus 1 equals greater than or equals to 0. So that means the x is greater than or equals to half. And it is a negative 2x minus 1 for x smaller than half. So that means using the number line, this is half. Greater than half is positive, and smaller than half is a negative. And for the right part, it's always positive x plus 4 for both regions, because it is not modulus function. So that means in here, we can solve it for x greater than or equals to half. That means 2x minus 1, positive, yeah, equals to x plus 4. So this is x equals to 5. Check, is 5 greater than half? Yes. And for x smaller than half, so negative 2x minus 1 equals to x plus 4. So negative 2x plus 1 equals to x plus 4. So negative 3x equals to 3. So x equals to negative 1. Is negative 1 smaller than half? Yes. So we take it. So we take both answers. So the solutions are x equals to 5 and x equals to negative 1. So if we use the stats, we can see that the zeros is half. So we can draw it, put the half at the x-axis. And then we draw the line x plus 4. So that's the blue one, y equals to x plus 4. This one is the 2x minus 1. And this one is y equals to minus 2x minus 1. And you can see the solution, the intersection points are negative 1 and 5. So the same. This is the exercise. You can try to do this exercise and then check it in the next video. I will upload the other video for the exercise. You can check the link in the description. Solving modulus inequalities. To solve the modulus inequalities, we can use the same method as solving the modulus equation. So we can use the stats and also the algebra method. But sometimes the sketch can help us to determine the region easily. So let's see the example. Absolute function of x plus 4 is smaller than or equals to absolute function of 2x minus 1. So to solve this, we can just use the equation equals to this one. And since both sides are absolute value, so I can guarantee that both sides will always positive. So I can just square it. So this is square. And I can expand this, x squared plus 8x plus 16 equals to 4x squared minus 4x plus 1. And then I can simplify 3x squared minus 12x minus 15 equals to 0. And then we can factorize. So this is 3x, this is 3x. 15 is 5 and 3. So this is 5, 3. To make it negative 12, so 3 is times minus 5, become minus 15. And then plus 3. So become negative 12. So that means x equals to negative 1 or x equals to 5. So we can draw it for absolute value of x plus 4. It will be positive for x greater than or equals to negative 4. And it can be a negative for x smaller than 4, negative 4. So we can put the negative 4 on the x-axis here, and then draw x plus 4, y equals to x plus 4, and this one is y equals to negative x plus 4. The blue one is x plus 4 and negative x plus 4. And for the right part, modulus function of 2x minus 1 can be positive 2x minus 1 for x greater than or equals to 1 over 2, and it's negative of 2x minus 1 for x smaller than 1 over 2. So draw 1 over 2 on the x-axis, so this one. And then that means for the greater than half is y equals to 2x minus 1. For smaller than half, it's y equals to negative 2x minus 1. So from here, we can see that the intersection points are negative 1 and 5. So it cuts here and here. Now, the inequality is the absolute function of x plus 4 should be smaller than. So that means the blue one, x plus 4 is the blue one, yeah, should be smaller than the red one. The blue one, x plus 4, should be smaller than the red one, to x minus 1. So from the graph, in which region are the blue graph is under the red graph? Smaller than means below. So in which region the blue lines are below the red line. The blue line below the red line, it's only happened in this region. So that means the solution of this should be x smaller than -1 or equals to, because there is an equal sign there. And the blue is below the red on this region as well. So that means in the region of x greater than or equals to 5. So the solution of these inequalities are x smaller than or equals to -1 and x greater than or equals to 5. Two answers. So from this example, we can see that the sketch help us to determine the position of the graph. In which region the one graph is below the other graph, or vice versa. In which region the first graph is on the second graph. So we can use the graph to see the position, and then it can help us to set the solution, the region of solutions. Okay, this is the example, and I have exercise, and you can write that. You can check in the next video, and that's for the inequalities. So you can check the discussion of the exercise in the other video. The link will be given in the description, so you can check it. Thank you and bye.